I'm gonna record this. And here's the thing about a cladogram. The whole idea is that you have. I'm just gonna draw a couple different organisms here. Here's one. Here's another. And there's a couple different kinds of organisms here. And all right. So if you have this bunch of organisms, which one's related to which one? And how closely related is one to another? Those are the questions that we have when we're looking at cladograms. How closely related is anything? And what you do, and the only thing you're doing is comparing similarities and differences. It's just that simple. It's really easy. It's fun. It's fairly quick. They'll usually give you a chart. So they'll say, let's just number these instead of trying to give some weird name to them. So they'll give you a chart where they list the different organisms. And then they'll list the different characteristics in that organism. So the organisms obviously 1, 2, 3, or 4. I'm just going to list the characteristics here. So at this, just the line, right? And then we could say 3 corners, 4 corners, and 5 corners. All right. So the only one that doesn't have a corner is number 4. So they all have a line. 4 doesn't have a corner, but all of them have at least 3 corners. All the rest. Number 3 has, number 2 only has 3 corners, doesn't have 4 corners. All the rest the other 2 have 4 corners. And only one of them has 5 corners, and that's number 1. Do you see how that works? Okay, that was quick and dirty, kind of a way to organize the characteristics. Now, why are we doing this? Because the idea is that if you have a characteristic, you inherited it from an ancestor. And what that suggests is that if you inherited it from an ancestor and you share it with someone else, then it's a characteristic that you both inherited from a common ancestor. Does that make sense? To give you a good example, and the more characteristics you share, the more closely related you are to the thing that you're comparing it to. So to give you a good example, or at least an example, and you can decide if it's good or not. If you and your parents, and then you got your characteristics from your parents, right? We're good with that. You got your DNA from your parents, which gave you proteins, which made you look the way you do. Thank you. Could you pass those out, please? And thank you. Now you go ahead and you have children. They have similar characteristics to you. Which do you think is more closely related? You and your child, or your child and your parents? You and your child are more closely related, and it's likely that they're going to look more like you.
He made me unlock the door back for her, the one that didn't even have the key.
Okay, that's good. So you have what ends up happening is that by counting how many characteristics you have in common with someone, you can look at how closely related you are with them. Does that make sense? And I think we all know that. We all do that. You look like your mom, you look like your dad, you look like your grandmother, that kind of thing. All right, so then we take this information and we put it on something called a cladogram, which is just a line that shows that this is the older side And then this is the newer. Now, on the line itself, you're going to put the characteristic. So here we would put line. So branching off this common ancestor, this is a common ancestor here, which means at this point, this creature, whatever it was, had a line, but then a bunch of different generations, a bunch of different evolutionary steps later, you ended up with a creature that had three corners, the triangle. Moving forward, oh, I'm sorry, that's not true. Yeah, the circle, the line is the circle. No corners. Then later, moving down the evolutionary, again, thousands, hundreds, thousands, tens of thousands of years later, an organism came along that had corners and had three corners. Then from that, it had a bunch of different evolutionary steps later, a bunch of different organisms, and you ended up with the triangle. A little bit further down, many thousands of years later, you had the evolution of four corners. And again, through many evolutionary steps, you end up with a square. And finally, and you can draw these in many different ways, but finally at the end, you have the development of five corners, and you end up with the pentagon. Oops, should have done it in red. So when we look at a cladogram, this is known as a cladogram, okay? I look at this cladogram and I ask myself, which of these had the most recent common ancestor to the pentagon? Can you answer that question? Which had the most recent common ancestor to the pentagon? The square. The square and the pentagon had the most recent common ancestor, which I would circle here. Which two are more closely related? The square and the triangle, or the square and the circle? Square and a triangle, because they had a more recent common ancestor. This is older, this is newer. So as you're doing this activity, you're going to get, you have it in front of you now, and then you can work in groups. Then you'll see that you're going to take all kinds of data and you're going to compare it. And one of the sets of data, the last set of data you're going to look is molecular data. And you're going to look at amino acids, amino acid 1, amino acid 2. You're going to have a whole line of amino acids. And you're going to have there'll be a shark, there'll be a dolphin, there'll be a whatever. And they're going to have their amino acid sequence. And then right underneath it, they'll have the DNA sequence. And where did you get the amino acid sequence? You got the amino acid sequence from the DNA. And where did you get the DNA? Where did they get their DNA? From their parents. And where did they get their DNA? From their ancestors. So if the amino acids are similar, the more similar the amino acids are to one another, correct? The more related they are. That seems fair, right? Since the DNA should directly be compared to their ancestor. Didn't I tell you about having your phone out? Okay, so put it away. Get it out of the way so I don't see it by you. That's all. Just put it off to the side. It's plugged in. So as long as you compare, the more similar they are, the more closely related they are. That's all there is to it. And what? So this protein is similar to this protein, right? Let's say these two are the most similar. Well, so what's the big deal? Is that the proteins are very similar, then their function is similar. So these two can function very much in the same area. If this is different, if this function is different because its amino acids are different, then it's going to be, then it's either going to work, that protein is either going to work better or worse than this protein. So this is either going to be better or worse than the protein that's different. And so what happens when natural selection comes along, if this protein is better, let's say the protein is muscle, and let's say the this muscle is better. So let's say this muscle is better, this version of the protein is better, and this version of the protein is worse. Okay, so the shark is worse with this muscle than the dolphin. The dolphin is better. So some natural selection happens. Maybe some giant shark starts to hunt dolphins and baby sharks. And these baby sharks have worse muscle. Who gets eaten? If the muscle is worse, so they're worse swimmers, you're saying the dolphin is going to be eaten. Is that what you want to say?
No, I thought you were talking about the
So if there's a giant shark that's eating smaller sharks or dolphins, and the smaller sharks have worse muscle, because they're different, right? The protein is worse. Which one's going to get eaten? The baby shark. So this one's out. It can't have babies. So which one survives? The dolphin. And in a couple thousand years, in 4,000 or 5,000 years, there's no sharks left. There's just dolphins. This is a bad example because that's not how it worked, but you get the point, right? That's how in other words, natural selection, you have to have differences. There have to be differences, or natural selection, you can't select, right? You can't choose one to be better at surviving than the other if they're not different. What makes them different? Their proteins. Where did they get the different proteins? Their ancestors. So consider that as you're answering these questions. All right, that's it. You guys are working on your own. Have a good day.